And welcome back to A Degree Hotter with Ashley. And I'm of course your girl, Ashley. And I hope you all have been good. I skipped a week of, filming, but I'm back. And, we're just gonna go ahead like always and get straight to the topic. So today's topic is lightning. The video probably won't be too long because it's just the basis of lightning. It's not too much. But lightning, of course, people hate it or are scared of it. I know plenty of people who hate lightning and are scared of it. And they postpone or cancel events when there's a thunderstorm and there's lightning in the vicinity because they should. It's very dangerous and should be very cautious of it. So lightning, of course, what is lightning? So of course, lightning is an electrical discharge in the atmosphere. It's a form of static electricity. And an example of static electricity is like when you rub your shoes or like your socks on a rug and then you touch something metal. That spark that you get, that's static electricity. So of course, about 100 lightning strikes hit our planet every second. So that's a lot. So imagine how much lightning, happens and comes throughout a whole year, even a day. The peak months for lightning, of course, are June, July, and August, which will make sense because that's also, the summer months, and that's when the atmosphere is moist and hot all the time, and that's when you get the most thunderstorms, and that's when they form. So, of course, those peak seasons will be in those months because that's when you get those, thunderstorms to form. Of course, if we're thinking about lightning and we want to kind of understand it, you got to look at it on a molecular level. And you have protons and electrons, and the nucleus and the atom and all those things. So protons are positive charged and electrons are negative charged. And then when they are, rotating and circling around the nucleus of an atom, and you get that neutral ion, that's when you have the same amount of protons and electrons. So of course, in the atmosphere, you have to have an electrical field in the atmosphere. And an electrical field is present in any region, exposed to charges. So when these charges are placed in our electric field, they experience either attraction or repellent. So examples of conductors and insulators in the atmosphere or on land when it comes to lightning, since you have to worry about experiencing that attraction or repellent. Normally, metals and water are very good conductors, and then you'll have insulators, and very good insulators more so for that is plastic and air. And of course you have air all around us, so they go through, and since air is a good insulator, and like I said, we have an electric field that really helps with lightning in the air. When different particles and things like ice crystals, ice and dust, anyway, when you have that in the atmosphere, they rise and they bump each other, all this, and then that's where you get the friction, and then that's where your lightning comes to play. Lightning can occur in within clouds, cloud to cloud, and also cloud to ground. They normally form in this steps called the step ladder. And this step ladder can cause ball lighting, heat lighting, bead lighting, the St. Elmo's fire, and also red sprites, blue jets, and L's. And they all have their different effects and meanings and how they form and things like that. But that's just a simple thing that lightning can do. It can, you know, create and, you know, do so much. It just can do so much. And, you know, also thundering, which is one thing that you always hear after lightning. You know, basically thunder is just the heat rising from these lightning bolts to the point that it gets a little too much and it just explodes. And you hear this big old thunder. I know people who, you know, normally don't like thunderstorms because of thunder. And thunder is honestly is harmless. It's really the lightning, like I always should tell people, that you should be worried about or afraid of, because that's the one that can be very dangerous. That's what can kill you. That's what can travel up to 62,000 miles per hour from the ground to, you know, from the cloud to the ground. And, you know, that's the one that gets 5 times hotter than the sun. And at least 1 out of 300 people a year get struck by lightning. So yeah, that's what you need to be worried about and watching for. So that's just some basics about lightning. Like I said, it was not a lot. It's kind of a short, you know, video, but I hope you guys enjoyed. If you have any questions or any comments, critique, feedback, just let me know down in the comments. And thank you again. You guys have a nice day.